Okay, welcome to this explainer. We are jumping straight into some incredibly urgent insights today. I was recently going through chapter 23 of Observability Engineering, and honestly, it kicks off with this incredibly powerful, almost urgent open letter addressed directly to CTOs and technical leaders. It's a massive reality check, and it's crashing into basically every engineering organization right now. The authors are laying out in no uncertain terms exactly why AI is about to drastically, fundamentally test your organization's engineering discipline. You see, we're rapidly moving away from an era where simply writing the code was the hard part. That era is over. Now we're entering a phase where the true bottleneck, the real friction point, is understanding what that generated code actually does once it's out there in the wild. The chapter frames this as a fundamental shift in our constraints, and it's a realization that completely flips how we need to think about modern software delivery.
And really, it all boils down to this existential question. Every CTO, every engineering leader needs to be asking themselves this right now. Is AI going to compound your advantage, or is it just going to compound your chaos? Because AI is fundamentally changing the rules of the game. It's about to accelerate everything, and I mean literally everything. Not just your code delivery speed, but every single mistake, every broken process, and every misaligned system your teams have inherited. Just think about it for a second. If an AI agent can generate thousands of lines of unverified code in just minutes, what happens when that hits production? Well, if you have strong, disciplined practices, AI is absolutely going to compound your advantage. But if your foundation is shaky, if you lack real visibility, AI is simply going to take your existing chaos and multiply it, making things break much faster than a human team could ever manage to fix them.
Which brings us to what we can think of as the AI illusion. For years, the tech industry has been utterly obsessed with delivery speed. The whole metric was, how fast can we write and ship a new feature? But the reality today, writing code is easier than it has ever been in human history. AI code generation has completely, 100% inverted the economics of software production. Generating the code is just no longer the bottleneck. Actually, scratch that, it hasn't been the bottleneck for a little while now. The new constraint, the true bottleneck that you as a leader have to manage today, has shifted entirely to how fast your organization can validate, understand, and learn from that code once it is actually out there running in a live production environment.
Now, to really grasp why this learning speed is such a critical bottleneck, the authors dive into this fascinating concept called sociotechnical debt. Now, obviously, you're intimately familiar with technical debt. We all are. But sociotechnical debt? That goes so much deeper. It happens when teams choose those quick, easy technical solutions in the moment. But those choices don't just create more coding work later. They fundamentally alter how your people actually work together. It leads to incredibly inefficient processes and deeply ingrained cultural workarounds. A classic example mentioned in the text is the fear of deploying on Fridays. We've all seen that, right? That's not a technical limit, that's a cultural workaround born from a sheer lack of confidence. You've likely been working around these kinds of cultural debts for years, subconsciously optimizing your teams to just not break things, rather than empowering them to actually make things better and faster.
The text brilliantly illustrates exactly how we ended up buried in this massive socio-technical debt by taking a quick look back at our history. Think back to 2009. Most teams were running a standard LAMP stack. Ah, the good old days, right? Back then, a single senior engineer could basically hold the entire system architecture in their head while they went to go grab a coffee. A relatively cheap monitoring bill and some basic predefined CPU alerts worked just fine because, well, the system was predictable. But today, come on, we have highly distributed, constantly changing systems packed with microservices, serverless components, and now non-deterministic AI agents. Human intuition simply no longer scales to meet this level of complexity. The duct tape and legacy monitoring tools that held together that 2009 stack, they are going to completely shatter at the 10x speed of modern AI development.
And to prove that point, here's a staggering statistic straight from the source material: 48%. The text points out that observability spend has increased by 48% year over year for 15 consecutive years. 15 years. It now accounts for a massive 20 to 30% of infrastructure spend at most companies. But here's the kicker. Despite this explosion in budget, the actual outcomes haven't drastically improved for a lot of teams. Why? Because organizations have historically just thrown money at the complexity problem. We chose to go broad. Buying more fragmented tools, creating hundreds of useless dashboards, and setting up thousands of noisy alerts, rather than fundamentally changing how we actually interrogate and understand our systems on a deep level. We essentially subsidized our socio-technical debt with massive, bloated software bills.
Which leads perfectly into this incredible quote from the chapter.
Despite that massive 48% year-over-year increase in spending we just talked about, your organization is very likely suffering from a severe case of cognitive dissonance. You are, quote, paying observability prices for monitoring outcomes. So what does that cognitive dissonance actually feel like on the ground? Well, it looks like having a massive budget, sprawling, expensive software stacks, while your engineers' daily workflows are still dominated by arbitrary static thresholds, painfully slow debugging sessions, and intense alert fatigue. It's that frustrating, all-too-common reality where your high-level executive dashboards might be completely green, but your actual production environment is poorly understood and your engineers are still panicking on a bridge call at 3 a.m.
So how do you actually know for sure if your team is stuck in this expensive trap? The chapter poses a brilliant, kind of painful rhetorical test known as the 2 or 3 people test. I want you to honestly think about your last major outage. When something breaks, do your incidents take, say, 15 minutes to resolve if your specific hero engineer happens to be online, but 45 minutes or more if they aren't? If your organization is still relying heavily on the operational heroics of a few senior rock stars and the undocumented institutional knowledge trapped inside their heads, rather than democratized, accessible observability platforms that literally anyone can query, well, then you have passively chosen a much slower organizational learning speed.
And here is where the rubber really meets the road in this chapter. AI is described as the ultimate debt collector. The authors highlight some eye-opening recent findings from Darragh. That's the DevOps research and assessment team. They discovered that AI simply amplifies the behaviors your organization already has. AI does not magically create organizational excellence out of thin air. In fact, Darragh found that teams with poor engineering practices actually saw decreased performance when they introduced AI. Let that sink in. If your daily operations are already full of lagging signals, alert fatigue, and massive blind spots, AI is just going to act as a debt collector. It will exponentially amplify those missing feedback loops because you're suddenly pushing complex AI-generated changes 10 times faster than you ever did before.
So the crucial takeaway here is that AI forces a really stark divergence in the industry. It's a fork in the road. It will either compound your strategic advantage or it will compound your systemic chaos. There's no middle ground anymore. It all depends on your foundational discipline. If you have strong, tight feedback loops, AI helps you move swiftly, testing and learning at a completely unprecedented scale, you'll pull ahead. But if you rely on inconsistent standards, fragmented tooling, and constant operational heroics from those 2 or 3 people, you are quite literally just scaling your risk. The faster you move with bad habits, the harder and faster your systems are going to crash.
And this concept illustrates exactly what happens when we blindly deploy without validating. When a deployment lacks granular observability, it creates a dangerous open loop. Basically, risk accumulates in the system much faster than we can ever hope to understand it. If your teams just deploy without capturing meaningful learning through precise, high-cardinality telemetry immediately afterward, you are flying completely blind. You're launching complex changes into the void, leading to unknown and potentially fatal consequences for your product and your users. It's an unsustainable way to operate in this new era.
To prevent that chaos, we absolutely must pivot to what the source text calls the feedback imperative. Closing the loop between development and production is quite literally the only way to survive the sheer, unrelenting speed of the AI era. You have to establish observability not just as a reactive debugging tool for when things go wrong, but as the true baseline for your organizational learning speed. The elite engineering teams described in the text, they do exactly this. They wire rich production signals directly back into daily development. They integrate telemetry right into their IDEs. They run immediate outcome checks after every single merge. They make production reality a core part of the developer's everyday workflow.
The authors break down this value creation into these essential feedback loops. Think about these as vital questions your team needs to be answering constantly, every single day. First, deployments. Did the change actually work in reality, not just on my machine? Then, code review. Is this code actually safe and maintainable long-term? Next, incidents. When something inevitably happened, what exactly broke and what fundamental assumptions did we have wrong? And finally, product development. Are users actually getting real value from this new feature? True observability acts as a shared sense-making layer across all of these disparate loops. It takes massive, messy, noisy production data and translates it into actual, actionable human understanding.
So, contrasting that dangerous open loop we talked about earlier, the alternative is a healthy, closed feedback loop. Deploy, observe, learn. This is the ideal state. In this model, every single deploy must immediately be followed by active observation and learning. You have to capture this insight while the developer's original intent is still completely fresh in their mind, literally minutes after they hit merge.
If you wait for a customer support ticket to come in 3 days later, or a massive system failure to force you to go look at your code, you've completely missed the window for fast, efficient organizational learning. You're already miles behind.
But how do we actually achieve that tight, closed loop in reality? The chapter emphasizes that this closed-loop learning is only made possible by a unified storage model. This is a massive shift in architecture and mindset. This is where telemetry isn't just an operations afterthought or a bunch of disconnected metrics, logs, and traces sitting in completely different data silos. Instead, observability is treated as a core product capability, engineered directly into the code by the developers themselves. By using wide, high-cardinality events in a single, unified data store, you preserve the incredibly rich context and relationships of the data. This gives your teams the sheer speed, flexibility, and explorability required to slice and dice data on the fly, finding those nasty, unknown unknowns that take down modern systems.
And when observability is fast, precise, and highly ergonomic for the developer, the results are incredible. You get multiple, continuous, rapid learning loops happening over time. The text notes that when tooling is great, the cost of curiosity drops. That is just a fantastic phrase, isn't it? The cost of curiosity drops. Because there's no friction, engineers stop guessing. They start actively asking complex questions of their systems. Imagine an engineer deploying a small change, immediately querying the telemetry, and catching a tiny memory leak in one specific pod before it cascades into a massive global outage. Because querying is fast and frictionless, they run these rapid deploy, observe, learn loops continuously, allowing the whole organization to move swiftly and confidently.
Now, this continuous, fast-paced loop is especially vital right now because of the sudden rise of agentic workflows. As the authors explain, AI agents completely shatter the old mental model that developers own the pre-production environment and operations own the post-production environment. Why? Because agents introduce absolute non-determinism. They make autonomous decisions on the fly, generating code pathways that developers literally could not have unit-tested for in advance. The only possible way to know what an AI agent actually did is by strictly observing its behavior in live production. You can no longer just test your way to confidence, you absolutely have to observe your way to confidence.
So the theory here makes complete sense. We know we need these tight loops. We know the AI era demands it. But practically speaking, how does the book suggest you actually turn your massive organizational ship around right now, especially if your teams are deeply entrenched in legacy workflows and siloed tools?
Well, Chapter 23 outlines a highly actionable 3-step playbook for leaders to completely redefine observability from an annoying IT cost center into a strategic accelerator. Step 1. Adopt the loop. You have to intentionally institutionalize the habit of observing and learning immediately after every single deploy, making it a non-negotiable part of your team's definition of done. Step 2. Treat observability like an internal platform product. Don't just buy a shiny new tool and force it top-down on your teams. Build it to genuinely enable developers, optimizing for their daily adoption and ease of use. And Step 3. Align your goals and spend to actual business outcomes, officially stepping out of the trap of paying exorbitant prices for legacy monitoring that doesn't actually facilitate fast organizational learning.
Of course, as a leader, you have to be able to measure this transformation to justify it. The text provides very specific metrics so you'll know these changes are actually working. First, you should see a shrinking median time to understand customer impact. Second, you should see a drastic increase in the percentage of material incidents caught by your own internal telemetry, meaning you find it before a customer ever has to complain on Twitter. And third, you should maximize the percentage of deploys that have an immediate outcome check. This looks like an engineer merging code, immediately bringing up their query and verifying the exact impact of their specific change in real time. By tracking these metrics, you mathematically prove to the board that your investment is paying down sociotechnical debt.
To prove this isn't just theoretical fluff, the chapter highlights an amazing real-world case study. Let's look at Finn, an AI customer service company. Their engineering team ships their monolith to production around 70 times a day. 70 times! And incredibly, each deploy takes only 8 to 15 minutes from the time code is merged to full production rollout. How on earth is a pace like that possible without constant catastrophic failure? Well, it's because they utilize highly detailed, granular observability practices that serve as a real-time safety boundary. Their teams are structured to truly own their code in production, and they have the rich telemetry required to instantly see if a deployment caused a regression, allowing them to roll back or fix it in mere minutes.
Darragh Curran, the CTO of Finn, beautifully summarizes this entire dynamic with a quote in the chapter that really stuck with me. He says, "If shipping is your heartbeat, then understanding is your breathing."
Let that sink in for a second. Shipping frequently is absolutely essential. It's the heartbeat of a modern competitive company. But true understanding of what you just shipped, that is the breathing. If you are shipping constantly but have no rich observability, you are effectively a biological system that is sprinting on a treadmill while completely holding its breath. You are eventually going to pass out.
When your organization uses precision observability to breathe deeper, you pull in the vital context needed to survive and thrive. That oxygen fuels sharper engineering decisions, drastically faster fixes, and ultimately much, much better products for your users. Tying it all back to the threat and opportunity of the AI era we started with, breathing deeply is quite literally the only way to harness the incredible, fast-paced upside of AI code generation while safely containing its massive, unpredictable downside. You have to breathe to survive the sprint.
Ultimately, your mandate as a technical leader today requires a complete paradigm shift. You must realize that since the economics of code production have permanently inverted, meaning the code itself is now incredibly cheap and incredibly fast to generate via AI, true engineering rigor must now live in your system's feedback loops. The rigor is no longer just in writing the perfect syntax on a whiteboard. The modern engineer's job has shifted from being a fast typist to being a complex system investigator. The real high-value engineering work is now deeply understanding the complex socio-technical system that your rapidly generated code interacts with in live production.
I'm going to leave you with this final provocative thought from the source text to take back to your teams and really chew on. When AI pushes your code generation and deployment to 10 times its current speed, will your developers actually be steering the ship with clear, granular visibility, or will they be dangerously blindfolded, just along for the ride while the entire system drifts into chaos? The choice between compounding your advantage and compounding your chaos ultimately comes down to your visibility. Thanks for exploring this chapter with me on this explainer. Catch you in the next one.